So this is the outline of these workshops. On day 1, which is this talk, I will provide introduction to ImageJ macro language. I will show you how to record and edit our image analysis workflow and introduce the basic concepts of scripting such as loops, conditions, and array. This is suitable for biologists with no previous coding knowledge. And if you already have some experience in scripting in other languages, you can also join from the day 2. On day 2, we will go through the first example of image analysis workflow. This example will show how to perform cell counting in batch and other bits and pieces that needs to be considered for batch process. On day 3, we will go through the second example of image analysis workflow. This example will focus on handling multiple images in ImageJ and also handling raw microscopy images using bio format in batch. On day 4, we will go through the last example of image analysis workflows. This example will show how to measure co-occurrence of fluorescence markers and also how to get results out and log in to our custom table. Once we have gone through above examples using these as a template, hopefully you can start to write your own macro for your own images at your own pace. After the workshop, we can also have follow-up sessions. University of Melbourne researchers will be able to book in a one-on-one consulting session with me after the main workshop to get feedback or advice on their macro writing. So, why do we need macro writings? First, the macro will allow us to automate image analysis tasks. For example, if we want to count cells from our images and if we have hundreds of images, instead of processing each task repetitively, which will involve many clickings, we can batch process this. Second, we can also customize our image analysis workflow further. For example, if we want to count the cells that are positive to another marker rather than every cells, we can set up such conditions using macro language. Also during this process, all image processing steps will be saved as a text file, and this allows us in keeping records on which parameters or which plugin we have used and in which order, etc. So we can always go back to check those details. Lastly, once our workflow is set, we can also share this with our colleagues so our analysis can be reproduced in the same way. Using the macro language has some advantages that this language is easier to learn compared to the other programming languages. It's mainly because the most of functions can be recorded using microrecorder, so we can access to the script environment easier, and most of recorded commands mirrors the menu name of the ImageJ, so most of script is intuitive and easy to read. The disadvantage of macro language is that the process is rather slower than some other languages. Also, this language can be used only in ImageJ, unlike general language like Python. Also, this language doesn't support library formats and limited in implementing a real-time interactive input. Regardless of these downsides, macro language is still a very handy tool when it comes to the bioimage analysis using ImageJ. So let's start on day 1, Introduction to ImageJ macro language. Let's start with an example problems that this is my image and I want to count cells automatically. The first thing we need to do is to find out the optimal analysis workflow, something like this. And depending on your problems, this workflow will be very different. And if your problem is a common topic, you will be able to adapt from example workflows covered in our other FIJI workshops, or you can also get more examples from these websites shown here. In this workshop, we will focus on automating any existing analysis workflow. So when we have this type of workflow, we can record each steps using macro recorder in ImageJ. Most of the commands and plugins can be recorded in macro recorder. Then we can run recordings using the script editor in ImageJ, using this run button. Or we can record each steps, and then we can use Batch plugin, which is an inbuilt plugin in FIJI. And in this plugin, you can set up input folder, output folder, and also the output formats. And also you can run specific files using the file name filter here. We can copy and paste our recordings and run batch by clicking the process. Then the same process will be repeated on every image in the input folder, and the last active image will be saved in an output folder. We can also test on the first image of input folder before running the entire batch process, and also we can save our scripts as a text file. So let me demonstrate how to use macro recorder, script editor, and batch plugin. Let's try recording a simple process doing nucleus counting and area measurements. So what we will do is first open the image and then set the threshold to make a binary image. And then split the touching object using watershed and then run analysis particles to get the area measurement. So on my desktop, I already have made the shortcuts for FIJI and the demo image folder. We can start FIJI by double-clicking the icon. Once the FIJI has started, we can open the macro recorder via plugins, macros, and records. On the macro recorder window, you can check if the recording option is set as macro. Then I will open the first image to process from the demo image folder and from the cell counting folder, and it is nuclei-1.tif. I'm going to open this image by dragging and drop. I'll just minimize this. On the recorder, we can check that the select window command has been recorded. When I record the image processing steps, I find that arranging the windows without overlapping helps checking the recording easier. If the image is taking up too much space, we can resize the image window using plus or minus key on the keyboard, and we can place the recorder next to the image. If we have resized the window, the zoom in and out command will be also recorded, and we can delete this as this is not a necessary step on our image analysis workflow. On the opened image, next step is to set the threshold via image adjust threshold. From the threshold window, we can try different automatic threshold method. And as I am selecting different method, you can also see that these are all recorded automatically in the recorder. In this example, I'm going to select the default method and going to click apply button to make our image into the binary mask. If you look at the recorder, after the select window command, we have some recordings that we don't need on our scripts, as these were from my testing on different method before selecting the default method. So I'm going to delete this part. As you can see, curating the recordings as you go and making it neat and tidy is very important, as otherwise, at the end of the step, there are so many commands have been recorded, and it will be very hard to figure out which is the correct one I would like to use. Sometimes you will see these commands recorded with double slash. This is the background commands that was recorded together, and most of the time it is not required in running the script, so we can remove this one too. So now we have 3 additional lines, where the first one is for the auto threshold method, where we have chosen default method, and dark means that we have used dark background option. The set option command with black backgrounds being true is the command that was used when converting our image into binary image, along with the convert to mask command when we have clicked the apply button. On the next step, I will use watershed. Watershed is useful in splitting touching objects, as you can see here and here. You can find watershed menu from process, binary, and watershed. You can see these objects are now split, and also the watershed command is recorded. Before we run the measurements command, we need to set what we want to measure through Analysis, Set Measurements menu. Here I am interested in area only, so I'm going to click area and click OK to close the window. And you can see the Set Measurements command is recorded with the area option. So we are ready to run the measurements. To measure all separated objects, we can use Analyze Particle menu, which will perform connected components analysis. In this Analyze Particle window, I will set the size filter to 100 square microns to remove small objects, and set the circularity filter as 0.5 to grab the round objects only, and select the show option as masks to check measured object in the new mask image. Also, I'm going to display result table and summarize table. As I'm measuring the area of object, I'm going to exclude particles that are touching edges. If you want to know more details on this Analyze Particle options, please see our FIJI for quantification workshop video, which you can find on our websites or our YouTube channel. Once it is all set, we can click OK. This will generate the mask image and the summary table and the result table. The mask image will be generated as inverted LUT mode, and we can bring this back to the correct LUT by image lookup table, invert LUT. Or you can also find the LUT button on the toolbar, so you can click this and select invert LUT menu from there. After this, on the recorder, you can see that there is additional commands recorded. In Analyze Particle commands, you can see that the size filter, circularity filter, up show option, and the other options that I have ticked, which is display result, exclude on edges, summarize, has been recorded. And on the next, inverted LUT commands is also recorded. You can check the summary and result table that were generated here. So all of our image processing step has been recorded. We can copy this into the script editor in FIJI. To do so, we can click this Create button from the recorder window. This will open the script editor with all my recordings copied. From this editor, we can save our script by going to the file, Save As. I'm going to save the file on the desktop and going to name this file as 1_cellcounting.ijm. The file extension for ImageJ macro is ijm, so please remember to type .ijm at the end when saving the file, as this doesn't come up automatically. We can now test if our script is working properly, so let's close all the windows and images except the main FIJI bar. On the desktop, I can see my micro file that I have just saved. And I'm going to reopen the image I have used before from the cell counting folder by dragging and drop. And also I'm going to reopen the macro by dragging a drop, and this will open the script in the script editor. From the editor, we can click this Run button, and this will run all the processes automatically. This itself will already save us from many clicking. So now let's try to run this process on another image from the same folder. When I open another image and click Run, I'm getting this error message saying that it cannot find nuclei1.tif window. This is because we have the command in the first line that requires this specific image. If we want to run the rest of scripts to other images, the easiest way is to remove the first line. In this way, the rest of commands will be applied to any active image window. So if we run it again, this will process on any opened image. So now we have the script that will work on any active image. We can use this on the batch plugin to process the entire folder. Batch plugin can be found in Process, Batch, Macro. On the main text box, remove any existing text if you have some, then copy and paste the code from the script editor. Then we can select the input directory where our images to process are located, which is the cell counting folder. On the output directory, I'm going to select the different folder which I have named as cell counting output. If you don't have it, you can make a new folder. It is important to have your output folder on a different location to your input folder, as otherwise the input image may be overwritten by the outputs. After this, we can set the format of our output image. In this example, I only need it for proofing purpose, so I will set it as JPEG. If you're going to use the output image for further image process, then you can select TIFF to avoid any data loss. Sometimes our input folder may contain multiple types of files, so I'm going to set the filter to select TIFF files only by typing .tiff in the file name contained text box. We can then test on the first image of our input folder by clicking Test. You can check the first image is opened correctly, and the result table appears the same way as before. And now we can process the entire folder by clicking Process button. And you can see the images are processed in the background and all the results are generated. We can also check the output folder and we can see the mask images are saved as JPEG format. So from this demonstration, we now know that we can record ImageJ commands using macro recorder, and we can save it as a text files for future reference. We have also seen that we can run our scripts as many times as needed using the script editor or batch plugin. So this will be good enough for simple tasks. If we want to perform more complicated tasks, such as setting a condition or setting a loop or create a custom table, we need to understand the macro language, and we'll get onto this on the next step. For the rest part of day 1, I will go through some basics of macro languages. The first is the syntax. Syntax is like a grammar of programming language. All programming languages have a set syntax, so the commands need to be written in a specific manner. In this table, you can see that the same process such as assigning value of 500 to the variable named number is written differently in different languages. ImageJ macro language is based on Java, so this follows the same syntax. The most important thing to know for ImageJ macro language syntax is that the macro language is sensitive to the case of the character. As in this example, the word that starts with uppercase and lowercase is identified as different object. So this number and this number will be a completely different variable. And this 5 and this 5 will be a completely different value. Another important syntax is that all commands must be ended with semicolon. Semicolon tells ImageJ that the assignment is done, and missing a semicolon will generate an error. These two are the common rules that apply in macro language, and I will cover more syntax that is specific to each element as we go through them. Elements are essentially the building blocks of programming language, just like an alphabet in English. In the FIJI script editor, each element is automatically color-coded, so it is much easier to read than the text written in just black and white. And also, mistyping can be detected easily if we also pay attention to the color. So this color scheme will be used throughout this talk. The most basic elements is the number and the text. When we use the numerical data, the number will be detected either as integer, which is a number without a decimal point, or as a float, which is a number with a decimal point. We don't need to address these two types in macro language, but we can differentiate these if we would like to. The next element is the text. Text is also called as string. In ImageJ macro, text should be inside the double quotes, as otherwise it will be detected as a different element, which is a variable, which I'll cover in the next slide. When we have multiple numbers or text, we can also make a list of them, which is called array. Array can be defined with new array function, where the items are inside the red brackets and each items can be separated by comma. Another element is variable. You can think variable as a container that stores elements like text, number, and array. This container has a name and a value, and in this example, I have a variable that is named as my variable, and I can store values such as string, number, or the list of them. Variable is very useful when we want to execute the same code several times while some value inside the code needs to be changed. I will show you the example in the next step. When we want to assign a value to a variable, we need to use the equals operator. So for example, to put value 100 to my variable, we will need to write this way. Or assign a string or assign an array is written this way. Another element is a built-in function. Macro functions execute actions. There are many built-in functions in ImageJ, and you can find all of them from this link. As shown in the previous demonstration, most of ImageJ menu or any action we take can be recorded. But there are a lot more actions available in this list, and some of them will not be recorded in the recorder. So when you'd like to do something while writing ImageJ macro, and if you cannot find it from the ImageJ menu, please go to this website and search for it. You will be able to find most of actions you can imagine, or even discover some actions that you didn't know about. FIJI script editor also has auto-completion functions based on this list, so you can start from there too. When we start writing any script, one of the functions we will use a lot is the print function. This function will simply print any value within the bracket onto the log window. Or to print out the value in array, we can use array.print function. Now with the elements we have covered so far, I will show you how we can use those elements in our script. For example, let's say we have calculated a percentage of some ingredients of samples. We can print out the name of the sample and the percentage in different way. We can print out the name alone, and then the percentage. Or we can also print out the name and the percentage in the same line. Or we can also add additional string in between the value to make it clear. This works well so far in the current script, but what if I want to change the value of percentage, say, to 90? Then I have to change the value for all 4 lines. But we can make this process simpler by using the variable. So at the beginning of the script, we can assign variables, one for the name and one for the percentage. Then we can replace the value to those variables on our print functions. And let's check if this also works. So it works, and when we need to change the value, in this case, we can simply change the first 2 lines instead of the entire script. In another example, when we decided that we like to use this style of printing, we can also use the same style with the same variable and repeat in the same code. Variable is essentially a container where the value can be changed anytime. So after we have used this print function, we can use the exactly same code by reassigning the variable with a different value. Please note that this will be the first activity you will need to do after this lecture today. Another element is an operator. This is the whole list of operators we can use in ImageJ macro language. These operators have default precedence levels. For example, the multiplication is on the level 2, so it precedes the addition, which is on the level 3. In this example, what do you think the value for cal variable? It'll be 5, and we can check the value with the print function here. For the numeric calculation, we can use bracket to define the order of operation. So if we put the bracket here, the value for cal will be now 8. And yes, we can check using the print function. So this operator plus will add values for numbers or even variable if the variables are assigned with numbers. We can check the value with the print function as well. This operator can also be used for text. If we use this plus operator in between the strings, what do you think the value of this text variable will be? This plus will concatenate or combine 2 strings into one. It is also working in the same way with variables if the variables are all strings. What if we use this plus operator between the string and the number? In this example, string hi and number 4 will result another text as a hi 4. In this example that starts with number 4 and then plus hi, the program will give you an error message. And this is because when the program reads the codes from the left to the right, it will first see the number 4 and then plus. So it will try to do the addition with the next value, and then seeing it's a text, it cannot perform addition anymore, so it gives an error. Well, does this mean that we cannot add numbers at the start of string? Technically, this is possible by adding an empty string like this. Then the program will not be confused and just perform concatenation. In general practice, it is better to avoid using any number at the beginning of the string if possible. Just to avoid any unnecessary error like this, because as our code is becoming more complicated, it is more likely that we will forget about this. So now we know what kind of operators are available. We can practice by making our own calculator, and this will be your second activity. The next element is the comment. Also, I will explain how to detect an error from our codes, which is called debugging. Writing comments is a good coding practice. Comments are entered using double slash, and we can add comments to explain what each segment of our script is doing. And this explanation is most of the time for my future self than any others. Without the proper comments, when we revisited our own code, it will take a long time to remember on what we have done. Another useful information we can add for other people is on how to use this script. For example, which software or which plugins are required, and also the contact details of us as an author, so anyone who receives the code can ask questions and use it properly. Comments is also useful to comment out the code. If we want to keep some codes in the script without completely deleting, and we can use this double slash to comment out. Comments can also be applied on multiple lines if we use this slash asterisk at the start and asterisk slash at the end. While we are coding, especially when we are learning, it is also good practice to validate the codes as we go. We already know that the print function is very useful for tracing what's going on within our script. If we have many things to check, we can also check all together by making an intentional error within our script. We can do this by typing some random text, which will be recognized as a variable, but without assigning any value. When we run it, this will generate an error saying unidentified variable. Well, this is not important as this was our mock error, but the important thing is the debug window, which you can get by ticking this option before clicking OK. This will open the debug window, and from there, we will be able to see the entire picture of variables and the error details. As your third activity, please try to open debug window on your previous calculator script.